Good day, and today we will be simulating this problem with chemical reaction from the textbook Elementary Principles of Chemical Processes, 3rd edition by Felder and Rauscha. So this problem can be found in chapter 4 of the book. The problem is a catalytic reactor is used to produce formaldehyde from methanol and the reaction shown below. The reaction is methanol yields formaldehyde plus hydrogen, and as we notice, they just have one stoichiometric coefficient. Then, a single pass conversion of 60% is achieved in the reactor. The methanol in the reactor product is separated from the formaldehyde and hydrogen in a multiple unit process. The production rate of formaldehyde is 900 kilograms per hour, and we are then asked to calculate the required feed rate of methanol to the process, that is in kilomoles per hour, if there is no recycle. Second is we are asked to prove that we have enough information to determine the required fresh feed rate of methanol in kilomoles per hour and the rates at which it enters and leaves the reactor, given the parameters that the recovered methanol is recycled to the reactor and the single pass conversion remains the same, which is 60%. Then we are to perform the calculations. So basically, if you will be doing this manually, calculating it manually, for the letter B, we will be using a formula for the degree of freedom analysis to prove that we have enough information. But basically now we will be solving this problem or simulating this problem using the DWSIM. Okay, but before we proceed to the DWSIM, the unit operations that we will be using for this problem is, first, we will be using the reactor, catalytic reactor. Second is we will be using a separator for this, because we have to separate the methanol in the reactor product from the formaldehyde and hydrogen. And we will be using recycle block, because according to the letter B, the recovered methanol is recycled to the reactor. And we will be also using the specification block, because we have to specify that the production rate in our product streams should have 900 kilograms per hour of formaldehyde. Okay, in the DWSIM, the compounds that we will be using is the methanol, formaldehyde, and hydrogen. Okay, so for the property package, we will just be using the Reynolds law. Reaction, this is a conversion reaction, so let's name it as formaldehyde production. And we should include the methanol, formaldehyde, and hydrogen. Base component is methanol, and the stoichiometric coefficient is just 1, right, as you notice in the reaction, but for the reactant it should be negative, so -1. For the product is positive. The phase is mixture. We are given the 60% single pass conversion. Okay, so for the system of units, this should be in kilograms per hour and kilomoles per hour, so we will just be using these units, sample units. So kilograms per hour mass flow rate and kilomoles per hour for the molar flow rate. Okay, so for the we will be using here conversion reactor. So let's just use the shortcut for the inlet and outlet streams. Okay, so here this is pure methanol, right? So since this is pure methanol, for the compound amounts, for the methanol it should have 1 and 0, except changes. So here, this reactor, let's name this as a catalytic reactor. Okay, this is the catalytic reactor. So for the catalytic reactor, our calculation mode should be in isothermic. So for the reactors, what usually goes out, this is in a vapor stream. As you notice here, vapor stream, because here the vapor phase mole fraction is 1, so that is vapor stream. And what goes out below is the liquid stream. Okay, so now let's find out where's the formaldehyde. So in the vapor stream, there's a 0.4 formaldehyde, and for the liquid stream, there's 0.08 formaldehyde. So why are we looking for the formaldehyde? Because we are given the production rate of formaldehyde, which is 900 kilograms per hour. So to clearly see the formaldehyde, to account all the formaldehyde, so we will be using mixer so that it will be easier for us to use the specification block. Okay, so the inlet stream, vapor, liquid stream, and the outlet stream here. Okay, so let's rename this as our product stream. So our product contains 0.25 methanol, 0.375 formaldehyde, and the same amount for hydrogen. So we have to specify this, that it should contain 900 kilograms per hour of formaldehyde. So we will be using master property table to clearly see that. So for the master property table, for the property here is just, we will be having this mass flow formaldehyde. So currently the mass flow of formaldehyde is 2024.11 kilograms per hour. So we should make this as 900, approximately 900 kilograms per hour. So then that's why we will be using a specification block. For the specification block, our source object is the product. Our source property will be molar flow of formaldehyde. And for the target object is the pure methanol. Target property is molar flow of methanol. So the dependency expression now is according to the single pass conversion, right? So let's go back here. So the single pass conversion, we are given 60%. So the single pass conversion has a formula of moles reacted per moles fed. So we are given the 900 kilograms per hour formaldehyde, so we need to convert that into kilomoles per hour. So by using its molecular weight, which is 30.031 kilograms per kilomole. So since according to the reaction, the formaldehyde has 1:1 ratio with the methanol, so 1:1. So then we are then given now here the moles fed, which is 49.948 kilomoles per hour. So we will be using this expression or this equation for our dependency expression. Okay, so specification block here is 900 times 1/30.031 divided by 0.6. Okay, so now let's try solving the flow sheet. Okay, here. So we now have 899.85 kilograms per hour of formaldehyde in our product stream. So then we are asked, right, to the feed rate of methanol to the process in kilomoles per hour. So according to the DWSIM, the answer is 49.9484 kilomoles per hour. So that is the methanol that enters our reactor. Okay, so that's it for our letter A. Now let's move on for our letter B. For the letter B is that suppose the recovered methanol is recycled to the reactor and the single pass conversion remains 60%. We are asked to calculate the fresh feed rate of methanol and the rates at which it enters and leaves the reactor in kilomoles per hour. So this same setup. So conversion factor, you'll be using conversion factor. Okay, inlet, outlet streams, and then the energy stream. Okay, so the same here. Right, so this is pure, or let's just say this is the methanol entering. So let's say this is the reactor. This is the catalytic reactor. It should be the calculation mode, it should be isothermic. So for the methanol entering, since this is pure methanol, so the same for the compound amounts, it should be 1 and the rest should be 0. Okay, so the same, this is vapor stream, this is liquid stream, and we need to use a mixer to account all the formaldehyde. So inlet 6 and the stream 7, the outlet. Okay, so basically this has just the same setup with our letter A. Okay, so now here this stream, it contains 0.25 methanol and 0.375 formaldehyde and hydrogen. So we need to separate this methanol from the formaldehyde and hydrogen, since the methanol recovered should be recycled to the reactor. So we will be using a compound separator for that. So for the compound separator, our inlet streams is the stream 8, the outlet, and then the energy stream. So let's rename this as our separator. Okay, so this stream, it should have a formaldehyde and hydrogen. It should contain the formaldehyde and hydrogen only. And for this stream, it should contain also the methanol, just methanol. So let's say methanol recovered. Okay, so to specify that it should have just 100% methanol and the rest here is the formaldehyde and hydrogen only, so we will be using the calculation parameters for the separator. Separation factor specified for, let's have the outlet stream 2, which refers to the methanol recovered. So let's have the value to be 100%. Okay, so let's check. Methanol recovered, okay, that's 1, and the formaldehyde, okay, they have equal amounts. Okay, so basically here, okay, we will be using a recycle block, right? Because the methanol recovered to be recycled back to the reactor. So methanol recovered and the outlet stream. Okay, here. So we need another stream for the fresh feed rate. Let's say, let's rename this as the fresh methanol. Okay, so since this fresh methanol, so that is pure methanol. So changes, and then we will be using a mixer to mix the fresh methanol and the methanol recovered. Okay, mixer, fresh methanol, and the stream 11, and the outlet stream is the methanol entering the reactor. Okay, so the same here, it should contain 900 kilograms per hour of formaldehyde. So to clearly see that, we will be using master property table. That, okay, so the master property table is for the formaldehyde and hydrogen, it should contain 900 kilograms mass flow of formaldehyde. Let's have the mixture. Okay, this one. Currently, it has 2024.11 kilograms per hour. Okay, so we will be then using the specification block, because we have to specify in the formaldehyde hydrogen stream, it should contain 900 kilograms per hour. Okay, so let's have the source object formaldehyde and hydrogen, and our source property is the molar flow of formaldehyde, and our target object is the fresh methanol, and our target property is molar flow methanol. So the dependency expression now changes. It will be 900 times 1 over 30.031. Okay, so now let's try solving the flow sheet. So then, now in our formaldehyde and hydrogen stream, it contains 903.018 kilogram per hour of the formaldehyde. So that can be just close to 900 kilograms per hour. So we are asked in the problem the fresh feed rate of methanol and the rates at which methanol enters and leaves the reactor. So according to the DWSIM, the fresh methanol that enters, feed rate is 29.969 kilomoles per hour, and the methanol entering the reactor, that is the fresh methanol and the methanol recycled is combined, so that is 50.1243 kilomoles per hour. Okay, and then the methanol that goes out from the reactor is 0.25 of 80.1988 kilomoles per hour. So 0.25 of 80.1988 kilomoles per hour, so that is 20.0497 kilomoles per hour of methanol that leaves the reactor. Okay, so basically in this problem, we just use the specification block to specify that in the formaldehyde and hydrogen streams in letter B, and for the product stream for letter A, it should contain 900 kilograms per hour approximately. Okay, so I guess that's all. Thank you so much.